are going to explain about project title Deep Convolution Forest, a dynamic deep ensemble approach for spam detection in text. The increase in people's use of mobile messaging services has led to the spread of social engineering attacks like phishing, considering that spam text is one of the main factors in dissemination of phishing attack to steal sensitive data such as credit cards and passwords. In addition, rumors and incorrect medical information regarding the COVID-19 pandemic are widely shared on social media, leading to the people's fear and confusion. This filtering spam content is vital to reduce risks and threats. Previous studies led on machine learning and deep learning algorithms approaches for spam classifications, but this approach has two limitations. Machine learning model requires manual feature engineering, whereas deep learning neural network requires a high computational cost. The main objective of this project was focused on the detection of spam in text by introducing novel algorithm called dynamic deep ensemble approach for spam detection and also known as deep convolution forest. Hardware requirements: we need operating system Windows, processor i5 and above, RAM 4 GB and above, hard disk 20 GB and above. Coming to the software requirements, we need to install Python with a version of 3.7. Methodologies: to implement this project, we have designed few modules. First one, upload SMS dataset. Using this module, we will upload dataset to application and then plot graph with the total ham and spam messages count. Second module, preprocessing and word embedding vector. By applying preprocessing technique, we will read all messages and then process messages by converting to the lowercase, removing stop words, applying stemming and lemmatization, and then applying word embedding algorithm to convert messages into neural vectors. Then third model runs smooth oversampling dataset. So by this module, we will apply smooth algorithm to balance dataset and then split the dataset into train and test, where application is used 80% of dataset for training and 20% for testing. Fourth module, run existing algorithm. As a existing algorithm, we have support vector machine and then input 80% of training data to the support vector machine to train model, and this model will be applied on 20% of text data set to calculate prediction accuracy. Fifth module, convolution based feature extraction. Using this model, we will train CNN algorithm to extract features and then will calculate accuracy of this model. Then sixth module, run proposed DCF algorithm. DCF algorithm is nothing but deep convolution forest algorithm. Using this module, we will extract the features from CNN algorithm and then input these features to combination of ensemble algorithms such as bagging, boosting and random forest to train a model, and this model will be applied on test data to calculate prediction accuracy. Seventh module, comparison graph. Using this module, we will plot a comparison graph between all the algorithms of accuracy. And eighth module, spam prediction from test dataset. Using this module, we will upload the test dataset messages and then DCF, deep convolution forest algorithm, will predict those messages as spam and ham. Now coming to the execution, first we need to open the code file. This is a code file consists of dataset file, and this dataset file consists of train and test files. And model file, this is the model file which contains .h5 files which contains algorithm information which can be loaded into the project code during runtime to utilize the trained model for various tasks such as making prediction on the new data or performing specific operations. Then next one, this is the main code file and this is the runbat file. This runbat file, instead of executing the program in command line interface, we execute Windows bat file to execute the code. By clicking double tab on this, it will lead to the user graphical interface which is interactive to the program to the user. And you can see the graphical user interface, and first button, upload SMS dataset. This SMS dataset is, when we click on the first button, it will lead into the graphical user interface, and this you can select the spam trained dataset. Now you can see the graphical representation and also the samples which were there in the dataset. This is the count of the class which has ham and spam. X-axis the label of the classes and y-axis the count of the ham and spam indicates. Now close this file, and second button, pre-process and word embedding vector. Clicking this button, you can see the words embedded into the numerical format, and it is also smoothened into the, like, how many hams are there and spams are there in the dataset. And next one, run smooth oversampling dataset. By clicking this model, you can see the ham and spam algorithms of the different types of smooths are overlapped. So this smooth synthetic minority oversampling technique is one of the most common used oversampling method to solve the imbalance problem. See, before you have the samples of spam is 7 to 9 and ham is 482. So we have balanced the both spam and ham dataset classes in the project. It aims to balance classes distribution by randomly increasing minority classes example by replicating them. So smooth synthesizes new minority instances between existing minority instances. So this is the function of smooth oversampling dataset. And now run existing algorithm. In this existing algorithm, we have support vector machine. This support vector machine, by using the hyperplane, it trains the dataset and predicts the accuracy. So it will leads in the background back console. It runs and predicts the output in the graphical interface with the accuracy and also graphical interface. So now you can see here the confusion matrix of support vector machine, which has the positive predicted leads and also true classes. So now close this file, and in the graphical user interface you can see the accuracy of support vector machine too. Now convolution based feature extraction. By clicking this model, you can see the convolution based CNN algorithm was extracted features based upon the dataset. Now you can see the convolution features extraction, confusion matrix, predicted classes and true classes, and also you can see the accuracy on the graphical user interface. And now run propose DCF algorithm. DCF algorithm is nothing but deep convolution forest. This deep convolution forest model employs a cascade approach inspired by the structure of deep neural network and deep forest. Each level receives processed feature information from its prior level and outputs its processing outcome to posterior level. Now you can see in the user graphical interface here the accuracy of a DCF algorithm and also confusion matrix of DCF algorithm which was predicted. Now close this graph, and now click the button comparison graph. By clicking this button comparison graph, you can see all the accuracy levels which was predicted and used in this project. So in the x-axis the labels of the algorithm, and in the y-axis the frequencies of the accuracy, F1 score and precision score. From this all algorithms, we are founded that DCF algorithm is scoring best accuracy in this model, in this project. And now last button, spam prediction from test dataset. By clicking this model, you can see the dialog box open and take the test dataset, select it and load it. Now you can see the samples and also text samples, and it indicates that it is spam or ham after the arrow which was given in the graphical user interface. Now exit this code. And go to the conclusion. So based upon the proposed project, in this project, model utilizes convolution and pooling layers for the feature extraction, along with the base classifiers such as random forest and extremely randomized trees for classifying text into the spam or legitimates one. So moreover, the model employs assemble learning procedure like boosting and bagging. As a result, a model which was high precision recall F1 score and accuracy is DCF algorithm, that is deep convolution forest algorithm, that is deep assemble convolution learning algorithm.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.